Section 8.2 is on page 466, talks about integration by parts. Now, you are aware of one technique of integration. We're going to add 4 more to that, plus you already know the technique of U sub. We're going to amend that as well. So, we start off with this section by 3 integrals that you should definitely have known, and if not, let me remind you. I expect you to know what the integral of tangent of x dx is anytime you see it. I expect you to know what the integral of secant of x dx equal whenever you see it. And I expect you to know the integral of dx divided by a squared plus x squared. I'm going to derive those for you just so that you wouldn't come back and say, my previous teacher didn't really derive it. Here it is. So those 3 integrals come up a lot more than you like, and not coincidentally, I'll mention why those come up once we talk about trig substitution. So, if I look at the integral of tangent of x dx, well, this is really the integral of sine of x over cosine of x dx, and this brings you back to the previous semester. If you look at this and recall, what did you let u equal? We always let u equal the denominator of a fraction, the exponent, a log if there is a log, an inverse trig function if there is an inverse trig function, the inside of a radical, right? If I let u equal cosine, and hopefully now you're going to start working by, would du be this? And that's how we're going to start improving your u sub. If I let u equal cosine, then the derivative of that will be the sine. That will work. Off by a constant is never a problem. So, if I let u equal a cosine of x, du is negative the sine of x dx. And if I make my substitution here accordingly, I will notice that this is the integral of, that is my u, and du is right there. The only catch is there is no minus. Well, there's an easy fix. I could divide both sides by a negative 1, and since the negative 1 is a constant, I could just drag that up front, and there it is. And this would be negative the natural log of absolute value of u plus c, and that would be negative natural log. And what was u? U was my cosine of x plus c. This is a fine answer. Some books take this and make it a power, and they say, well, natural log of cosine of x raised to the negative 1 is 1 over cosine. That makes this the secant of x. So either answer will do. I really don't care much. So I expect when you see the integral of tan of x, you know automatically. Either you're going to say that's negative natural log of the cosine of x plus c, or you're going to see that's natural log of secant of x plus c. I believe this book uses this notation. That's one of them. The second has a nice trick, and don't ask me how did they figure that out. If you are looking at secant of x dx, again, the reason for this, those 3 integrals arise a lot more than you like. So what somebody figured out is that if I was to multiply by secant of x plus tan of x, basically a 1. If I multiply by 1, which is the only thing allowed in math to multiply with, that would be secant squared of x plus secant of x tan of x over secant of x plus tan of x dx. And if I let u equal, again, the denominator, wouldn't you say du is derivative of secant is secant of x tan of x, and derivative of tangent is secant squared of x dx. And do you notice magically that happens to match? So all what this is the integral of, there's my u, and there's my du. That will be natural log of absolute value of u, but I know what u is. It's right there. So whenever you see this integral, I assume you know that's the natural log of the secant of x plus tan of x plus c. And if I look at the last piece, so I'm going to shrink this a bit now that we finished this problem. I'm going to squeeze that right here. If I look at the last case, if I factor an a out, a squared out, wouldn't that be 1 plus x squared over a squared dx? And if I let u equal x over a, wouldn't du be dx over a? And if I cross multiply, wouldn't that be, so a squared, the integral of, and let's see how this plays. My u is right there, but it's being squared. And a 1 there. And if I take dx, that's really a times du. And wouldn't this cancel one of those? And I'll be left with 1 over a. And isn't that the inverse tangent of u? And what's u? So wouldn't that be 1 over a, the inverse tangent of x over a plus c? We're gonna do tons of integration in this class, a lot more than you like. Among the most integrals that we see, those three come up the most. I just want to point out also, in case you were wondering, and I know you wonder a lot, if you take the integral of cotangent of x, that is the opposite in sign, and instead of cosine, it's the sine. If you take the integral of cosecant of x dx, I'm getting clumsy there, that would be natural log of, instead of secant, it's the cosecant, instead of a plus, it's a minus cotan of x. Alright? Just in case you come across them. So this is what I memorized. I could derive those two simply by multiplying by a minus. That would be it. Now, besides those, let's continue the trend and remind you of a u sub just a bit. Let me get these problems out. Now, we want to undo the product rule. We want, if you take u multiplied by v prime, that would be the derivative of u times v plus u times the derivative of v. So I could say that is v times du plus u times dv. And if I solve for u dv, that is, if I move this to the other side, I could say that u dot dv equals u times v prime minus v du. And now if I integrate, I will get the integral of u dot v prime minus the integral of v du equal the integral of u dv. And the integral of u dot dv will equal, if I integrate by fundamental theorem of calculus, an integral will undo a derivative minus the integral of v du. So this is really derived from the product rule, but you would notice that, you will notice what this does. My first attempt will always be a u sub, and if the u sub doesn't work, then I glance at a problem, and let's discuss really what this does. Here, if I look at a problem, and it seems there is a function in there multiplied by dv. If I look here, you'll notice those switch rows, that is dv and v, and this was u, this is du. What that does, that will switch the order of the integral. So initially you might not be able to integrate this, but you might be able to integrate this. How would this benefit me? Well, let's see. I notice whatever I choose, and you're going to choose those two. Whatever I choose u to be, this is the derivative of that. That gives me a hint. So whatever I choose u to be and dv to be, eventually I will end up looking at the integral of the derivative of that and the integral of this. Well, what can I eliminate by taking enough derivatives? Well, obviously that would be a polynomial. Let's start with the easiest case possible. So I'd like to do a couple of problems. One that is a basic problem and one that's not, and let me show you really quick. So looking at page 471, I'm looking at problem number 40, and I do want to point out the book says evaluate the integral by using such and such. I don't on your test, I say integrate or evaluate the integral. So I glance at this problem. My first attempt will always be a u sub if that does the trick. Here I would let u equal, well, the argument of an angle, right? Remember how that works? Keeping in mind that now you should start thinking about, well, is the derivative of that an x squared? Well, it is. The derivative of this is 3x squared dx. So I could manipulate this integral and say that's the integral of the sine of my u. And if I really glance at x squared dx, I could say off by a constant is a small price to pay. That is 1/3. And what do you take a derivative of to get the sine? Negative the cosine of u plus c. And we know what u is. U would be an x cubed. And there it is. Versus, so this is on page 471 in our book. If I look at this problem, and I'm going to alter that just to match for now. I am going to do that problem in a sec. What I want to do, I want to make a problem like it, but a bit simpler as a first problem. I'm going to call it 2 prime, the integral of x, the sine of x dx. Let's say instead of 40, I have number 2. Well, here I would think of, well, let's see, if I let u equal the angle, du is dx, this is the integral of, and let's see how this works. That would be the sine of u, and dx is really du. And do you see I still have, well, nothing changed. Instead of x sine of x dx, it's u sine of u du. So this didn't get me anywhere. That's not the way to go. If that's the case, I glance at the problem and say, okay, well, I have another trick up my sleeve. I just learned that recently, which is like right now. I am going to think of integration by parts because I am aware that if I let u equal x, the derivative of polynomial will eventually disappear. If I let u equal x, the difference between the u sub and the integration by parts, between u and dv, between those two, you're going to choose the entire integrand. So if I let u equal x, automatically dv is going to be whatever is left over between u and dv. The entire integrand should be chosen. And I know what I need. I need a derivative of this. Well, the derivative of, and I'm going to actually, in case you didn't pay attention last semester, it's du dx equal, the derivative of x is 1, and if you cross multiply, that's where it is. And to get v, I integrate. And wouldn't that be negative the cosine of x? So, according to this formula, I'm going to write it again. The integral of u dot dv is going to be u times v minus the integral of v du. So this is going to equal u times v minus the integral of v du. Negative times a negative is a positive. And by the way, the plus c you added just at the end once. And wouldn't this be negative x, the cosine of x, plus, what do you take a derivative to get cosine? The sine of x plus c. So in this video, I'm almost done. I'm going to do this problem on the next video. For now, let me just convince you that that's true. And how is that? Well, we're saying this is the antiderivative of this, which means if I take a derivative of this, I should get this. If I take a derivative of this, if I take negative x cosine of x plus sine of x plus c, and I take a derivative, I should get the integrand. Well, let's see. This is going to be the product rule. Derivative of the first times the second plus the first times derivative of the second plus derivative of that plus 0. Of course, this and that cancel out. Negative x times negative sine of x is positive x sine of x. And there it is. And that's how it works. Now, I'm gonna wrap what I need in the next video.